In this video, I'm going to show you how you can run an ANOVA using Meta, but also I'm going to show you how you can potentially do something similar using Metafor. In Metafor, we're going to be using the regression procedure, so some of the parts in the regression procedure can get a little bit involved. If you feel like you need to know or understand more about what I'm saying, please feel free to stop by and we can go over the details. Well, as usual, I set my working environment to go into the folder that I want, and I have already opened a file that I created that contains the details that I want to be using. So the first thing that I'm going to do is to read the file, and for that I go and read this data file called data.mta. And if you go and look at the variables, you'll see that in fact this is one of the files that we have been using before, except that this time we have another new column that is called allocation. This variable allocation determines whether the assignment to the groups was alternate, random, or systematic. So once that we know that, then we can go back to our syntax file, and we can see that this time if we want to run this meta-analysis using the package meta, we need to use a different command, a command that says meta bin. Bin stands for binary data, and you can see that I have here some of the variables that we have used before. The format for using meta bin is that you enter the number of events, so in this case it will be the number of positive cases of tuberculosis for the treatment group, and then the next section you'll see that is the sum of all the cases for the treatment group, so it's T-pos plus T-neg. Now the next option will be the number of events for the control group, so in this case is C-pos, and the next subcommand will be the sum of the control cases, so it's C-pos plus C-neg. After that we have the data where the file can be found, and then the last parameter is the type of effect size that we're going to be using, and in this case we are using odds ratio. One thing to realize is that Meta does not use the logarithms of the odds ratio, so some of the results may be off because of the way that some of these things are calculated. So anyway, we run this meta-analysis and then we ask for the summary of the results, and as we have seen before, the meta package will give me both the results for the fixed effects and for the random effects. So this will be the odds ratios associated to the full model. Just like we've done in the past, we also run a forest plot, and we see the results for all the cases. Notice that in this case it's talking about events and total number of events for the experimental case or the treatment, and the number of events and the total number of cases for the control. And see, it also indicates that it's using the odds ratio. Okay, so we are back on RStudio, and now what we're going to be doing is running a ANOVA. Notice that nothing really changes except for the fact that now I have this by var that is indicating that the variable that needs to be used to do the ANOVA comparison is the variable allocation, and then it's going to assign a label to that is group, but other than that the rest of the parameters are the same that from those that we ran before. So we run that, and then we look at the summary, and just like we had before, this time it's going to give me the fixed effects, the random effects, and tau squared, h and I squared, the test of heterogeneity. This is for the full model, and below you have the results for the subgroups. In this case it will be for the fixed effects model, so it's telling me how many studies are on the alternate group. In this case we have 2, 7 for the random group, and 4 for the systematic. and here we have the odds ratio for each one of those, the Q value, the tau squared, and the I squared, the test for subgroup difference, and you can see that in this case it's saying that I have a between groups difference that is significant. So we know that at least one of the groups will be different from the others. And then we have the results for the subgroups for the random effects. Once more, we have the number of cases, or studies, the odds ratio, and the Q, the tau squared, and the I squared. Notice that in this case, the test for the subgroup differences is saying that I don't have a significant difference. So depending on the specific model that we're running, we may either have a significant or a non-significant result. So now let's see if we can figure out what group may be the one that is different. So for that, we're going to start by running a forest plot, and here we have the result, and you can see that the random effects, if we were to compare the fixed effects, we have here that the alternate is sort of very different from the effects for the random and for the systematic. So chances are that the alternate is the one that is going to be creating the significant difference as far as the fixed effects is concerned. Now compare that to what we get from when we look at the random effects model. Look at the size of the confidence interval for the alternate, and you can see that there is pretty much an overlap between the effect size for the group alternate and the group random and the group systematic. So that explains why we don't get to see a significant difference for the random effects model. Now, as I promised, I'm going to show you how you can run something that may be sort of equivalent but using Metafor. So the first thing that we need to do in Metafor is that we need to compute the effect size and the variance, and I hope that this looks familiar to you. So we are saying that we're going to be using the odds ratio, and then we indicate what are the different parameters that we're going to be using, and then we say where is the data file and that we want to append the results to the file. So we run this command, and then if we go to the file, you'll see that now, in addition to all the variables that we had before, now we have the estimates for the effect size and for the variance, just like we did before. We could just type data.mta and it will give me the results. In this time, you can see that they don't fit in one single row, so it has a second set of columns where it shows the variance. Then we're going to have to do some magic to make this work. So what we're going to be doing is that we are going to be creating 3 new variables. One that will contain ones if the values are in the random category and 0 everywhere else. Then for the alternate, we're going to be doing the same thing. So we're going to create a new variable that is going to be called alternate, and it will have ones if the group is alternate and 0 for everything else. And then finally, we're going to be doing the same thing for systematic. So we do this for all 3 variables. And now what we're going to be doing is running a regression model where we're going to be doing some dummy coding. The way to do that is that we're going to be doing in Metafor, we're going to be doing the assignment. And here you can see that you have a command that says mods. Mods in this case stands for moderators. So what we are doing is indicating to Metafor that now we're going to have some moderating variables, and that we want Metafor to be able to include those variables into the model. And the other thing that is unique about this is that you notice that we are only talking about the alternate in the systematic. Because of the way that we did the assignment, what we are doing is creating a model with dummy coding. So we are going to run that, and we get the results of the model. So a couple of things that we need to pay attention to is just like we have been doing before. For the Metafor, we will have for the random effects models, we will have an estimate for tau, for I squared, for H squared, and then the estimates for the residual heterogeneity or n of the moderators. Notice that the moderators is saying that you don't have a significant effect. So in other words, it's saying that you don't really have a difference between the three groups. Now, how do we read this? Well, because of the fact that you were running a regression model using dummy coding, the estimate for the intercept will be in fact the estimate for the random group. The estimate for the alternate. In order to get that value, what you need to do is to sum this value, the value for the intercept, plus this value for the alternate. And then finally, to get the estimate for the systematic, what you need to do is once more sum the value for the intercept plus the value of the systematic. So if we want to get an estimate in odds ratio for the value of the random, what we need to do is to enter this value into my calculator and then find the inverse of the natural logarithm. Now let's see if we can find what was the value that we had before for the random. So for the random effect, for the random effects model for the random group, we had 0.3570, and you can see that, well, it's sort of close. It's not exactly the same number, but perhaps you can make the point that they are similar enough that you are okay with that. Now, I said that if we want to find the estimate for the alternate, what we need to do is to first enter the value for the intercept, 0.9921 negative, and then sum the result of the alternate. So we sum 0.3852, get the result, and then we find the inverse of the natural logarithm for that. So it's 0.5450. Let's see what was the value for the alternate. It's 0.5395. So again, it's not perfect, but you can make the case that it's kind of close. Okay, finally let's calculate the value for systematic, which will be 0.9921 negative plus 0.5596 equals, and then the inverse of that, and the value that we get is 0.6488. So let's see what is the value. 0.6411. Okay, well, perhaps it was the one that was the closest. This is the closest that you can get to estimate something similar to an ANOVA in the Metafor program, which is why I wanted to share with you how you can calculate this using the package Meta, which is more straightforward, and it also shows you a really nice example of what the chart looks like for when you have different groups.